what does it say about a linear function? It's highlighted. Does anybody have their book open? Sophia, what does it say?
A function whose points lie on a straight line and the function is graphed.
So we talked a little bit about this yesterday, except for we used proportional relationship. So a linear function is a proportional relationship. It's a straight line. So it's a function whose points lie on a straight line. And in our book today, we're going to work a lot with tables and graphs. We're going to continue from yesterday. But now we're going to talk about functions. We're going to call them functions instead of proportional relationships. Okay. So for the first example, they give us an XY table. In the book, it goes across, which is fine. I, for whatever reason, like to go down, so I'm just going to copy the same information, but I'm going to put it going down. So under the X, they have 1, 2, 3, 4. And under the Y, they have 6, 8, 10, and 14.
Wait, what's that number? The 1?
This?
No, the Y.
6. Sorry. The 6 got tangled up in my Y tail. Okay, so we're going to check to see if this is a linear function. To do that, there's two ways. One, which is what we did yesterday, is to make them into a fraction, right? So I would have 1/6. Then if I reduced 2/8, what do I get? 1/4. If I reduce 3/10, I can't. And if I reduce 4/14, what do I get?
2/7.
Thank you. None of those are the same. So this answer, this is not going to be a linear function. That means it's not going to be a straight line. It can still be graphed. It's just going to be more of like a wave. Another way to check. So now I'm going to rewrite my table. I'm going to use all the same numbers. Another way to check is to check the change between the x's and the y's. So you have to keep the x's all together, and you have to keep the y's all together. So the change between 1 and 2 is 1. The change between 2 and 3 is 1. 3 and 4 is 1. They were all plus 1, right? We added. So far we're on track for a straight line, right? Because those are all the same. Does that make sense? You guys with me? So now we're going to do the same thing on the other side. The difference between 6 and 8 is a +2. From 8 to 10 is a +2. From 10 to 14 is a +4. So those were not the same, which means the answer is also, again, no. Not proportional, not a linear function. It's not going to be a straight line. So whichever one you like better is fine with me. Just trying to give you options. Okay? Sheldon, question?
So if you do the +1 and +2 thing,
Yeah,
you can do that for every single one.
if it's in a table.
And then okay, if what?
If it's in a table,
Okay, and then if the 4 was a 2, it would be yes, right?
correct.
Okay.
Let's do one more the new way. So XY. Again, this one is in your books on page 99. It goes horizontal and I like to go down, so I'm going to make mine vertical, but that's where the numbers come from. -6, -3, 3, and -12. Yes,
Can I solve it?
sure, tell me.
Um,
So from 2 to 1,
I thought, is there like, can you divide, like, look at, like, cause like they all go into each other, like, the x goes into y 3 times 3.
so that's yesterday's. So that is one way to do it, right? So over here, we've got, if we made these into fractions, -2, 6, which would be -1/3, right? From yesterday. That's from yesterday. And he's right. Ethan noticed that they're all going to be divided by 3. They're all going to be the same. Right? -4. Oh, the 12 is positive. Sorry. That was my fault. Yes, ma'am.
Wait, I let you.
I was hoping to do this a new way, but he wasn't here yesterday, so I just wanted to confirm that he was
Okay.
right. Yeah, yeah. So if we do this a new way, if we're trying to check between them, we want to see the difference between them. Just going to rewrite it so it's nice and clean. Dane.
So it would be yes, right?
So this is yes, yeah. These were all the same, so this is going to make a straight line. That's what yes means. It's going to make a straight line, okay?
Does it matter if they're negatives or
It doesn't matter, but they all have to have it, right? They all have to be the same in order for it to be yes. But it doesn't matter if there's negatives or positives. All right, so the distance, because this one's a little bit different, but so I want to get through this one the new way. So from 2 to 1 is -1, right? From 1 to -1 is what? -2, okay? From -1 to -4, -3, -3. Okay, so those are not the same. Those are not the same. Okay? Now let's check on the right side. From -6 to -3. It's +3, right? Because the negative got smaller. Then from -3 to +3. +6? Is that what I heard? +6. And then from 3 to 12. +9. So these were all different. They're all different. So we have to check by putting them on top of each other. That's the final. So if they're all the same, like in our first one, oops, up here, right, except for 1, then you know the answer is no. But there's one more step if they've all changed that you need to check. So you just put them on top of each other like a ratio. So -1, we go this way. -1 over 3. This turns into -2 over 6, which is -1 over 3. And -3 over 9, which is -1/3. Okay? So this becomes a 2-step problem. Again, you can choose the one you like. Yes, Jacob.
Couldn't you just do the same thing again with the 3, 6, and the 9? Because you get 3 for each of them.
You notice that the change is the same, right? These all went up by -1. These all went up by 3.
Yeah.
Yeah, totally.
Okay. Would you be okay with that? Or you think
I am totally okay with that. So he said it once you check the difference between them. So over here we went up by 1, right? From -1 to -2. And then over here, we went up by 3, from 3 to 6. And then because the change was the same, the answer is yes. Instead of putting them into a fraction. It's just another way to determine, okay? These are all options. Yes?
So then why would it in like in number 1 on the new leg you wouldn't do the ratio?
So for this one,
Yeah.
I didn't do the ratio because these were the same, but then there was only one that was different. So that meant for our ratios, we would have had 1/2, 1/2, and 1/4. It was obviously not the same. There wasn't the same change happening. Okay, so like up here, right, these all went up by 1, and these were not the same. There was no like sequence. There was no pattern. But in this one, these all changed by -1. So from here to here was -1, from here to here was -1. Over here, from this to this was up 3, this to this was up 3. So there was a pattern, so that's why I checked the ratio. So since there was no pattern, I knew the answer was going to be that, 100%.
You can do the other.
You can
Just kidding.
Okay, you guys, turn the page. One more example. Discrete and continuous data. This is on the top of page 100. Let's talk about the difference. Grace, since your book is open, what is discrete data?
Data that involve account items such as numbers or of people or cars.
Okay. And what about continuous? Does anyone else have their book open? Yeah, go ahead. Tell me, what is it?
Wait, can you say what you want me to say again?
Continuous data. It's highlighted on the top of page 100.
Continuous data are data when numbers between any two data values have meaning. Use a solid line to indicate continuous data.
So let's talk about this. This should go in your notes. Meaning. Sorry. So, discrete data, right, is talking about specific things, like people. You can't have 2/3 of a person. You're either a person or you're not, right? Like a car, they used in their example in the book. You can't have half a car and make it work, right? Then it's not a working vehicle. Does that make sense? But like if we're talking about your age, for example, that's continuous because you don't just go from 13 to 14, right? Think back of a time like when you were Lincoln's age, when you were 7 years old. You counted when you were 7.5. You counted when you were 7 3/4. Remember that? No? You never did that? Okay. How about height? You guys have made fun of my height, which is rude, and I cried about it. But if you're between 5'3" and 5'4", it counts.